So, hello everyone. My name is Ilan from Vichy, and I'm a senior solution architect with AWS. With me, we have Hannah that will moderate the session today. So she will be watching the chat. Whenever you have a question, please post the question to the chat. Hannah will be able to answer some of the questions. And the other questions, I will stop from time to time, and Hannah will read out loud the questions so we can answer. I hope that you will benefit from this session, and let's get started. So, as I said, my name is Ilan Farmology, and you can, by the way, you can scan this QR code if you want to get in touch with me later. I've been in the IT business for about 30 years. So I started as an electronics and microprocessor engineer, and I've been working with networking and security for about 20 years. So I was actually fortunate enough to go through and to see several revolutions in the computing industry. So I started with the mainframes and terminals, and then I saw how people are moving to personal computers, and then connecting those computers with wires and creating a local area network, a LAN, and then adding to this local network data centers with servers that will provide services to this to the PCs that we have on the LAN. And then I started to see how those data centers are being connected all over the world and creating the internet. And lately, for the past, I think about 15 years, I can see cloud computing taking more and more active presence in the IT business. And now we are just on the verge of another revolution with the AI, ML, and generative AI. And the reason that I'm telling you this is not for you to try and calculate my age and to know how old I am and how back I go with this, but is to say something very simple, that despite all of those revolutions and everything that is happening, and the movement to the cloud and the cloud adoption, the basic things are still the same. So the basic things are not changed. It's just maybe a different language, a different way of implementing, but the basics are the same. And in this presentation that I'm going to have today, I'm going to talk about exactly those basic things and how we can use them, especially when we're talking about AWS and the cloud. So what do we have lined out for today? We will start with a short recap from the previous session that we had about the global infrastructure. Then I'll be moving to networking, talking about networking, about virtual private cloud, or VPC in short. We'll talk about how I connect this virtual private cloud to the internet or to other things that we have and we need connectivity to. We're going to talk about the concept of scaling, especially about the horizontal scaling, some differences between scalings. And then we're going to touch security. In security, we will talk about the model that we have in AWS, which is the shared responsibility model. I will explain it and the logic behind it. We'll then see how we can secure our network and how we can control the flow of data inside the network. We'll touch a little bit about identity and access management, so who can do what on the network that we have in the cloud. And we'll finish with the data security. So we do have a lot of ground to cover, and I hope that you will enjoy it. So let's start with a short recap from the last session about the AWS global infrastructure. So we already know that the AWS has a global presence. That means that we are spread around the world. We have what we call regions. We have now 33 regions. And in each region we have, in all of the regions we have now 105 availability zones and over 600 points of presence. That means that we have 600 points where people can actually directly connect to the AWS infrastructure. Near the names that you see over here, which are the names of the regions, there is a small number, and those are the numbers of the availability zones that we have in each of the regions. So let's talk about zoom in a little bit and see what we have inside the region. So each region is constructed in a very smart way because we need to make sure that when we provide services to customers, we need to make sure that we do not fail. Even though that we know that eventually everything fails, we need to make sure that we have a resilient and we have a fault tolerance between all the services that we are provided. So each region is constructed of, you saw already, the minimum is 3 availability zones. And each availability zone is actually a group of data centers between 1 to unknown number of data centers, but at least 1 data center per availability zone. And those data centers are interconnected between them. They are separated in terms of power supplies, in terms of networking, and they can compensate on each other in case of a load. And again, this is only for 1 availability zones. And we have a few availability zones, so they are also interconnected between them. And those availability zones are connected to the global AWS infrastructure through at least 2 transactions center. That means that those transaction centers are connecting the region to the global AWS network. And if any of them fails, the other one can take over. So it's a fully fault-tolerant infrastructure that makes an aim to be able and provide services at all time. So far, if there are any questions regarding this recap, it's a good time to ask. Okay, so let's continue and talk about networking. So we saw already what the physical network looks like and how it is constructed. But now let's take this physical network and understand how this physical network is being mapped to AWS virtual network. And also, I will want to share the way that we schematically show things, and you will, when we will go to websites and you will read about the way that AWS is constructed, you need to know how to read those maps or those charts. And this is what I want to look at right at the moment. So we have the region. And a region, we said that in a region we have also availability zones. And when you go to a console, you can select the availability zone that you will want to work on. So you can have availability zone, for example, inside a region which is named US East 1. There are several availability zones, as you can see over here. So when I log into the console in AWS, I can select the region and I can select the zone that I will want to work on. And what does it mean when I'm selecting the zone? When I'm selecting the zone, if you remember, there are data centers inside. So when I'm selecting a zone, I'm selecting also the data centers, or one of the data centers. I don't know exactly which one, but what we have inside a data center. A data center is actually constructed of racks. And those racks have inside a bunch, a lot of computers inside servers, and those servers are the hosts. And inside those hosts, inside those servers, I can run virtual machines. Those virtual machines are the instances that are running inside the availability zone. So if I'm selecting, for example, to run an instance in an availability zone, what I have, okay, what I will have is an instance running on a host that is a part of a rack in a data center in the availability zone that I've selected, in this case, availability zone A, in region, which is US East 1. Now, this is the physical part and how it is represented. But now, just like in ordinary data center, I can take those instances, I can take those computers, and those instances are running my software, which I select. I can take all of those instances and connect them to a network. This network, when we look at the data center, it's a physical network. It has wires, it has hubs, it has switches that I can connect together, and I have an IP address that I can assign to it. So in AWS, we have a virtual private cloud, which is represented over here by the pink line. And I say that all the instances are connected to this network. Now, just like in a data center, I can take this network, which is, in this case, is a very large network, and I can divide it into subnets. So I can decide that, for example, several instances are running in a subnet, and a subnet has a smaller network, as you can see over here. And it also has a dedicated security policy that is assigned to this subnet. And we will later on see how we can control this security policy and what exactly we have in those subnets. What else do we have? If we have a network that we need to communicate, inside the network, we also need to have the ability, for example, for the instance in A1, which is in availability zone A, to, for example, exchange information with another instance, which is in a totally different network in availability zone B. So how do we do this? For this, we will need to have routing tables. A routing table will take information, will take the information from the instance, for example, or that we have in availability zone A. And when I will need to say, okay, let's say that I want to speak with the subnet, with the instance that I have over here, with B2, then the routing table will know how to redirect the information and have the information connected and send the data from one instance to another. Those are the routing tables. And this routing table knows that, oh, if I'm looking for someone in network 10.0.3.0, this will be the path to reach it. For another instance, maybe it will be a different path. And those are the routing tables, and we will go into them a little bit in more details shortly. Now, so far, are there any questions?
Yes, now we have one question just popped in. Our instances are always part of VPC.
Yes, because when we run an instance, we want to run it in our VPC. This is the network that we have. It's a virtual network. The thing is that actually it's a very good question. So maybe I'll go back one step. We have a physical infrastructure. Okay, this physical infrastructure is, let's say, imagine to yourself that it is in your office, it's your data center. You have all your computers there, they're running. But when we're talking about this infrastructure, we're moving from a physical infrastructure to a virtual infrastructure. This virtual infrastructure is what allows us to have many customers many customers use a physical infrastructure and securely without accessing each other's data and without the fear that they will be overlapping. How do we do this? We create a virtual network, and this is the VPC. So we are moving from a physical layer to a virtual layer. This virtual layer defines the boundaries of where my instances or where my services are going to run. So each service that we run must be in our VPC, in our virtual private cloud. Okay, inside this virtual private cloud, we can have subnets, and we can have even more than one VPC. So we can have, for example, a VPC that is dedicated for development, and we can have another VPC which is dedicated for production. And I can connect between VPCs. It's like I have two networks. I can connect between networks. And we can also have policies, who is allowed to do what in the VPC. So this is actually the basic that allows many customers to use networking services, virtual network services on a physical layer. I hope that this answers the question. Give me a thumbs up if it's okay.
Yes, it does.
Okay, great. So let's move on. So now we have a VPC over here, and we have instances that are running inside the virtual private network. We said that it is private. So if it is private, the next question will be, okay, great. So what do I do? If it is only private and I cannot access anything, what good that it has? So the next question is, how am I going to connect this VPC to the world outside of it? And there are several ways or several places that I might want to go. So what do we have? We have a subnet over here, and this subnet has a routing table, and it is in availability zone, and we have a VPC around it, and everything is in US East 1. Now, there are some services that AWS provides. For example, if there is another VPC that we want to connect to. So we said that I might have a VPC for production and another VPC, for example, for development. So how do I connect those VPCs together? So whatever is going inside the AWS network, okay, inside AWS network, I can connect, for example, VPCs using what we have, a VPC peering connection. This will allow us to connect a VPC to a VPC. And there are also some services that we provide. For example, AWS has services, managed services that we can provide. We take care of everything. For example, you want to have a database, or you want to have storage where you can store your information. And you don't want to have it inside your VPC. You want to buy this service, you want to use this service. And this service is provided by AWS inside the AWS network. So you can use endpoint gateways. The endpoint gateway will allow your VPC to securely connect to services provided by AWS to you, and you can consume it as you want. So in order to connect your VPC to internal services, you will go through a gateway, to an endpoint gateway. And we also have a transaction gateway. A transaction gateway is a virtual router that allows you to connect your network to and route your information between the VPC and your corporate network. So if I have a network over here inside my VPC and I want to connect it to the corporate network, I will use a transit gateway. Now, the next question would be, okay, so I have a transit gateway. How do I connect actually to my corporate? In order to connect to a corporate, we have two ways to do it. The first way is to have what we call a direct connect. A direct connect is a dedicated line between your corporate And one of the endpoints that we have in one of the point of presence that we have around the globe, remember that we had 600 points of presence, so we can have a direct connection between your corporate and AWS Network. And this is a private connection that is only for you. It takes some time and it costs some money to do it. So what we can do, sometimes it is not needed to, or maybe I'm a small company, I don't need to have full-time connection, or I don't want to spend too much money to have my own dedicated line. Then I can use what we call a VPN gateway. A VPN gateway, it's a virtual private network. It's a way to communicate with the VPC and the corporate over an encrypted line. And this encrypted line is actually using the internet. So we use the internet, which I think most, if not all of the businesses today and homes are connected already to the internet. So we can use the internet, encrypt information, and this information will run through the internet, get into the VPN gateway, okay? And from the VPN gateway, we will be able to communicate with the VPC network. Now, in this case, the next question will be, okay, so how do I connect the VPC now to the internet? We say that VPN gateway is using the internet. And there are, for internet connection, so if you want to connect our VPC directly to the internet, we have also a couple of ways to do it. The first way is to have an internet gateway. An internet gateway, whatever is connected to an internet gateway, is considered to be a public network, okay? Because everything is directly connected to the internet. I will dive into this a little bit deeper in my next slides. And the other way to connect is using a NAT gateway. A NAT is short for Network Address Translation. That means that it will know how to take instances that live inside a virtual private cloud in a virtual network, and it will be able to redirect the information and send it to the internet. So this is what the network address translation will do. Let's have a deeper look on this part and understand better how it is working. So when we look at the VPC, we said that we have the ability to have subnets. In this case over here, we have a VPC and we have two subnets. You can already see that I have one subnet, which is, I call it a public subnet, and we shortly understand why. And we have a private subnet. And public subnets are connected to an internet gateway. What does that mean? That means that we have a gateway that is directly connected to the public subnet, and this gateway has a public IP address. Inside the VPC, if I have an EC2 instance, and EC2 is a short for Elastic Cloud Compute, so from now on, I will not say an instance. Usually, I'm used to say EC2, so EC2 is a Elastic Cloud Compute instance. It has its own private IP. This is not an IP that can actually be directly connected to the internet. And what the internet gateway is doing is that on one side it has a public IP, on the other side it is connected to the a public subnet, and it has a one-to-one address translation. That means that this instance, it seems like it has two IPs, a couple of IPs. One is a private IP, which will be served for internal communication inside the VPC, and the other one is a one-to-one translation. Yes, this is a one-to-one translation of everything that is getting to the internet gateway. So if someone is reaching the internet gateway in this IP address is translated and redirected automatically to this instance. So this instance now has direct connection from the instance to the internet using the internet gateway. And if someone from the internet will get to this IP, he will automatically be redirected to the instance itself. So we have a bidirectional communication that can be initiated either from the instance to the internet or from the internet to the instance. And this is why it is called public IP. The instance is connected to the internet. And if we think about it, then we need to make sure that we have some sort of security, how to protect this instance if it is directly connected to the internet. Good. Now, the next option that we have is to use a NAT gateway. And what is a NAT gateway? A NAT gateway is a device that is connected on one side to the private subnet, and on the other side, it gets its own IP address. Okay. Now, this IP address is public, and that means that this IP address is attached to the NAT gateway. And if an instance wants from the private subnet wants to reach out to the internet, the direction of the connection will be from the instance through the NAT gateway. It will translate the IP address to a public address and go out to the internet. Now, for this, we will need to have the routing table is saying, oh, if you want to go out, you're the instance, you want to go out to the internet. In order to do this, you should be redirecting the information to a NAT gateway. The NAT gateway will translate the address to a public IP address, and then you will be able to go out. And the same goes to other instances that are on the same subnet. That means that now we have many instances that are going out to the internet, and they are all hiding themselves behind this IP address. Now, if they're all hiding themselves behind this IP address, what happens if someone from the internet wants to reach those instances? Well, unfortunately, they cannot, because if I'm coming through the internet and I'm getting to this IP address, the NAT gateway doesn't know to which instance I want to reach. So when we're talking about NAT gateways, the information flow is only from the EC2 instances going out to the internet, but you cannot initiate a flow from the internet going to those instances. And this is why we call this subnet a private subnet. So just a short recap, when we're talking about public IP or public subnet, we're talking about a subnet which is connected to the internet through an internet gateway. Communication can be initiated from the EC2, from the instance to the internet, and back from the internet to the instance. For example, let's assume that we have over here a web server. A web server is connected to the internet. We want people to be able to reach our web server. So this is the way that we will be able to connect. We will have an IP address, which is a public IP address. People will come to this IP address and say, oh, this IP address is actually an internal instance with this address. It will be automatically translated one-to-one, and we will be able to connect to the instance from the internet. And when we're talking about NAT gateway, this is only in one direction, from the instance to the internet. Now, why do we need this type of connection? Let's say, for example, we have a service over here, a server which needs to get some updates from the internet so it can initiate communication, grab information to the internet, bring it back to the instance, and process it. Up to now, are there any questions?
All good.
Amazing. So let's continue and have a look. So we talked about Internet Gateway, and the Internet Gateway is connected to an EC2 instance. And we said that we have, for example, a web server. Or you know what? Let's say that we have an e-commerce website on this EC2 instance. This is great. So we're connecting this EC2. We installed on this EC2 an e-commerce website, and we're very happy. We're starting to sell, and everything looks fine. We're starting to do some money and have transactions, and it is great. But we have a risk. Why we have a risk? Because let's assume, we already know that things fail. Actually, when we have a quote, there is a very famous quote by Werner Vogels, which is the AWS CTO. And he says that everything fails all the time. And because everything fails all the time, when we are planning something, we need to plan for failure. And we need to design things for resilience. This is why you saw, for example, in the global infrastructure that we have not only one availability zones, we have 3 of them. We have not only one data center, we have a few of them. It's not only one transaction gateway, it's at least 2 of them. So everything is planned and designed for failure, and it's designed to be resilient. If something fails, we don't want to lose our service that we provide. And when you're doing a design for yourself, you need to think the same way. So if I'm looking now at this scenario that we have the e-commerce website, which is running on this EC2 instance in the availability zone, and everything is fine. What happens if this EC2 will fail? What will we do then? We will have very angry customers. We will lose money because we will not sell. We will hurt our reputation. This is not really good. And it can be also another issue. Maybe we have a problem with the availability zone. Maybe it's not your fault. Maybe it's our fault, and we have a failure in one of the availability zones. You will lose the connection to your e-commerce website. So what do? We'll do exactly what AWS did. We'll have 2 of them. So now we have another instance with the same e-commerce website, and it is installed on a different EC2 in a different availability zone. But wait a minute. Now, there is another issue, because we said that an internet gateway has a one-to-one connection to an instance. That means that if someone is coming from the internet to the internet gateway and they want to reach our e-commerce website, to which of the EC2 he will be redirected. So we are missing a link over here. And the link over here is called ELB, which is short for Elastic Load Balancer. The Elastic Load Balancer can get a request coming from the internet and redirect it to an EC2. Now the question is, which EC2 is going to direct the information? Bear in mind that both of them are running the same e-commerce website. So it doesn't really matter to which one of them he will redirect the request, as long as that it will be served. Now, there are a few ways to do this redirection, and this redirection can be done either to an EC2 instance. It can be also done to what we call a Lambda function. So it's a different type of compute. It can be done to different IP addresses. And the way to do the redirection, it can be done in a few ways. First one is what we call round robin. In round robin, we'll have, for example, customer number one will come through the internet gateway to the Elastic Load Balancer, and he will be redirected to the EC2 in zone A. Customer number two will go through the Elastic Load Balancer, and he will be served by the EC2 in zone B. Customer number three will go to zone A, and so on. And this is very similar to what we have, for example, in an airport. When we come, for example, to a passport control in an airport, we can see that we can select to which clerk we can handle our passport, and he can stamp it, and then we can go inside. But when we come to a very, very busy airport, we will see that we have a person that is standing and telling us, oh, wait a minute, I can see that the clerk in zone A, he is very busy and it will take a lot of time. Maybe it's better for you to go to the clerk that is on zone B. And that means that the other way that we can do the redirection is not round robin, just selecting one or another. We can also have another way of selecting which EC2, and this is according to the load. So if we see that we have, for example, a request that is coming from the internet, let's say that we have a very large order that is now being processed. So this EC2 in zone A will be working very hard, and it will not be able to handle more requests. Then the Elastic Load Balancer will redirect the next request to zone B, to the EC2 that we have in zone B. Okay, now what happens if we get more and more requests? And both the EC2 in zone A is overloaded and the EC2 in zone B is overloaded. Both of them are working very hard. So think about your laptop or your PC. When you have a software that is running, and this software is taking a lot of resources, what happens to your PC? It starts to be slow. It starts to process things very slowly, and then you say, okay, I think it's time that I will upgrade my PC, get some more memory, get some more CPU, so I can do my work faster. And we can do the same over here. We can now take an EC2, which has more memory, more compute power, and the same to do with the other EC2. And we can get a bigger chunk of memory and CPU power and scale them. This is called vertical scaling. So we take a small computer and we upgrade it to a bigger one. We take a small instance that we are using and we upgrade it to a bigger instance. And then it is fine, because now we have more processing power over here and more processing power over here, and everything is good. But now we have another issue, because our site is so great and our site is so successful and it's selling a lot. And it is now December and we are on the holiday season. And despite the way that we had, we have now two big computers that are serving, despite all of this, we still have an issue, because it is still not enough. We are now serving millions and millions of customers. So this vertical scaling is not helping us. The other way that we can do and introduce is what we call horizontal scaling. In horizontal scaling, we take more advantage of the virtualization that we have in the cloud. We have what we call an auto-scaling group. An auto-scaling group is a way for automatically spin up additional EC2 instances according to some criteria. So we talked before, the criteria was, let's say, load on the CPU. So those EC2 that we had in the beginning, they are overloaded. The elastic load balancer is redirecting the information according to the load. So he is aware that both of them are high loaded. He can make use of the auto-scaling group, and the auto-scaling group will say, okay, if this CPU has reached, for example, 80% of CPU power, and this EC2, again, have reached 80% of CPU power, I can spin up additional EC2s, and now I will divide the load between more of them, and I can grow as much as I want. And after the holiday seasons, so it's now mid-January, everyone is on vacation, no one is buying everything because everyone is with their family. I don't need all of those EC2 now. So I can shrink back and go back to having only 2 EC2s that are serving the website, that are serving my e-commerce. And this is why we call it elastic load balancer. The elastic load balancer, together with the auto-scaling group, allows us to have an elastic compute power that can shrink and grow according to the load that we have, and divide the information and divide the communication between all of those EC2 instances according to what we need. And this is true not only for facing internet. So sometimes we have also the same request or the same problem with internal instances. For example, we have our e-commerce website, which is very successful and is serving customers, but all the information, all the orders that are being placed on those e-commerce website need to be registered to a database. And if I have only one database over here, then I will have a bottleneck. The bottleneck will have, okay, I have enough e-commerce web service to serve the customers, but now the bottleneck has moved to, for example, to registering the orders in a database. So I can have also an internal private-facing elastic load balancer that can spin up additional database servers as needed. So this elasticity is working both for public-facing and for private-facing communication. And if we'll think about it, we talked before about horizontal scale and vertical scale. Horizontal scale means that I'm going to spin more instances, and vertical scale says that I'm going to have an instance which is bigger. And if the instance is bigger, that means that I will pay for it more. If I'm going to buy a new computer that has a lot of RAM and has a lot of CPU power, I'm going to pay for it more. And this is the idea. So the idea is, instead of having big computers with a lot of memory and a lot of CPUs that sometimes I will use it and sometimes I will not use it because I don't have the same requests all the time. It differs from end of December, for example, to mid-January. There's no reason to pay for this CPU power and memory power if I don't use it. I rather use smaller instances, which costs me less, and spin up additional instances as needed, and not grow vertically. Better to grow horizontally and pay less shrink and grow as needed, and not do it vertically if it is not really necessary. So far, are there any questions?
There has been some questions I've already answered.
Okay, so we can move on. Let's talk about security in AWS. And this is one of Vogels. He's the Amazon AWS CTO. And we take very seriously security in Amazon. In fact, this is the #1 priority that we have, and everything that we are doing is in mind of security. And this is something that forever will be embedded in the AWS culture. And let's talk about a concept that we're using, which is called the shared responsibility model. And in order to understand the shared responsibility model, let's have a look, first of all, of what we have in traditional on-premise data center with security, regarding security. So when we're talking about an on-premise data center, we have the infrastructure. So the infrastructure can be a data center that we have over here, or maybe a remote data center that is connected to our network. And we have hardware that is installed in this data center with maybe some software with it. We have some storages and databases and networking that we need to take care of and maintain them. And we have data that we need to work with. It can be either client data or server-side data that we're managing. And we need to take care also of the traffic. We need to make sure that the traffic is secure, that the traffic is encrypted, and everything is working according to the standards. We have our operating system that we need to make sure that they are patched and everything over there is of the latest version, so there are no security holes, and the networking needs to be secured as well. We don't want to have people just walking in the building, finding a network access point and connecting to this network without any supervision. We need to maintain our firewall and configure the firewall correctly, make sure that all the rules that we have in the firewalls are correct. Again, we need to maintain the platforms, the applications. We need to make sure who can access what on the network. And on top of all of this, as we said, the #1 priority is to secure the customer data. So when we look at this model of an on-premise security model, those are all the things that we need to take care of. Infrastructure, meaning building, meaning power supplies, meaning access to physical compounds, so who can access the building, who can access the doors of the data centers. Hardware needs to be maintained, needs to be provisioned, needs to be under contract. If there is a failure, we need to make sure that, for example, if a storage fails, we need to have a backup storage and so on. And everything over here is in the responsibility of the customer. Now, what happens when you move to the cloud? When you move to the cloud, we have what we call a shared responsibility, because some of the things we are doing. For example, we are the ones that are providing the data centers. We are the ones that are providing you with the compute power and the storage and the networking. And we need to make sure that all of them are power supply redundant and that no one can access the data centers without the permission. And only in AWS, it's very restricted. There are only several people that can actually access the data centers. And when we refer to the responsibility that we have in terms of security, we are responsible for the security of the cloud. Everything that the infrastructure that you use is under our responsibility. We are responsible for this, okay? What you're responsible is what you're running inside the cloud. So the customer's responsibility is for the information and data that it has in the cloud. We will provide the responsibility and we will share the responsibility. We will provide the security of the cloud, and the customer needs to make sure that he is responsible for what he is running in the cloud. For example, if he is installing I don't know, a Windows operating system. This Windows operating system needs to have an update. It is the customer's responsibility to make sure that the operating system is up to date. And if he has a firewall and he needs to configure the firewall, it is his responsibility to configure this firewall. Questions about the shared responsibility model? Good.
No questions in the chat.
Okay. So let's move on and talk about network security. So when we talk about network security, we already know that we have a VPC and we have subnets. Now, there is what we call a network access control list, or NACL in short. And this network access control list is actually, let's say, a firewall, okay? Every time that we configure a subnet, automatically with it, there is a network access control list that is being attached to it. By default, this network access control list allows all the traffic to travel in and out from the subnet. Okay, this is the default. And you have the option to configure this network access control list. And let's have an example to talk a little bit of what can we do with the network access control list. So let's go back to the demo that we had before. We have an EC2 running a e-commerce web server inside a subnet, and it is connected to the internet. And I want to protect this web server. I want to protect my e-commerce website. So what will I define? I will define that from the internet, the only communication that can go into this network, okay, when we say internet, that means if we say 0.0.0.0, this means everyone out there can access this EC2, this subnet, only on port 443, which is HTTPS. It's the secured layer to connect to the web server. And only this is allowed to go into the subnet from the internet. All other ports are not allowed to get access into the this public subnet. So despite the fact that it is in a public subnet and it has an IP, that means that it is, remember, there's a one-to-one translation over here using an internet gateway. Even though it is one-to-one translation of the address, I can now have a filter and make sure that only one port is allowed to get into this subnet. And we said that, for example, this EC2 is connected to a database. For example, a MySQL database that is running on a private subnet. So now do I need to protect this subnet? It is private. There is no one from the internet over here that can access actually, because it's a private subnet. But yet again, I will make sure that I will protect this SQL database. And the question is, how am I going to protect this SQL database? So the first question I need to ask is, who is going to access this SQL database? This SQL database is being accessed by the EC2 from the public subnet. So we need to make sure that this SQL can gain access, internal access, only from the subnet, the public subnet 10.0.0.0, through the designated port of MySQL, of this SQL. So we have an inbound rule that says that anyone from this network can get into this network, to the database network, to the private subnet, if they're coming from the public and on this port. So we have an internal and inbound rule over here for the database access. Let's go back to the public subnet. The public subnet now has two rules. Rule number one is to allow access from the internet, inbound rule, to allow access from the internet on port 443. And the second rule is to allow outbound access from our subnet to the SQL database. So now we have also an outbound rule over here that says that everyone from my network, from the public network, can go only on port 3306 out in the direction of the private subnet. And nothing else can actually go into the private subnet, because this is the only inbound rule we have. If I'm coming from a different IP or with a different port, I will be blocked. Questions so far?
No.
Good. So let's move on. The next thing that we have is security groups. And security groups, again, they act again like firewalls, but this time we're not looking at the network level. We are looking at the instance level. And remember, those instances are virtual instances. So we gain the same capabilities, but the capabilities are now on an instance level, which are virtual. The best way to understand this is, again, with some deeper dive. Let's have a look again on the scenario that we had before. So in the scenario that we had before, we have an internet gateway connected to a load balancer. And this load balancer is serving few of our e-commerce websites. So we have a scaling group over here, and we have a few EC2s. And those EC2s are directly connected to a SQL database over here. Notice that I skipped the load balancer over here for now, okay? But just for the explanation. So let's try to divide all those components into a logical groups of security. This is why we call it a security group. So the first security group that we have, we'll call it ELB, Elastic Load Balancer Security Group. And this security group gets requests from the internet, okay? It will probably be in port 443 because this is secure connection. They will have an inbound rule for port 443. What about our web servers that are running the e-commerce website? We can bind them together in one security group. We'll call it web security group. And this web security group will have the permission to access only on HTTP, only on port 80. Each one of them is running a web server, and web servers are running on port 80 with the protocol HTTP. So this is the second security group that we can identify. The third security group that we have is for the database. And the database security group is running on port 3306. So those are the groups that we have. Now we can define the relationship between those groups. So from the internet to the ELB security group to the load balancer security group, we will allow an inbound of port 443. For the web servers, for the web security group, we will allow access on port 80 with protocol HTTP. From where? Only from the ELB security group. So only if you are coming on port 80 from this security group, you will be allowed over here into this security group. And the next step that we will need to think is, how are we going to access the database security group? And the database security group can be accessed on port 3306 only if you are coming from the security group, which is web security groups. That means that only instances that belong to the web security group can access the database security group, can access this database. And there is no communication, there's no way to access the database security group from the ELB, because the only inbound that it is allowed is the web security group. Moreover than that, even inside the security group, we cannot access from instance to instance, because the definition of the security group says that you can access the web server that is installed on this instance only if you're coming from the ELB security group. So only if this is the path. You cannot access from one EC2 to another, because the source that you're coming from is not the ELB security group. Is that clear? Question so far?
No.
Okay, let's move on. So when we're looking at our virtual private cloud, okay, we're looking now at on our network. And in our network, we have compute services, and I've put some services over here. And I assume that not all of you are familiar with the AWS services. I want to, we already talked about EC2. We said that EC2 is a compute service. And I want to a little bit jump off my presentation and talk about Lambda, because Lambda is a very interesting service that we have. I'm not sure that all of you are familiar with it. So EC2 is just a virtual machine. Lambda is a very nice concept that says, okay, I have now a function. I'm writing the software and I have a function that I want to run. In order to run this software, I need to install an operating system. I need to run, for example, let's say that it is written in Python. So I need to have the Python libraries installed on this EC2, on this computer. And only then I can run my software. Lambda gives you all of this dynamically. That means that you say, okay, I have this function. I have this piece of code that I wrote in Python, and I want to run it, but I don't want to invest in getting myself a computer, installing everything on it. I just want to run my software. So we have a service which is called Lambda, and Lambda, you can provide Lambda your piece of code, and we will run it for you. And once this function is finished, the compute thing that you have to run this software will automatically shut down. And the next time that you want to run this piece of code, you can actually request, and automatically computer will be spinned up, take your code, run this code, and shut down automatically. And you will not pay for a virtual machine. You will only pay for the time period that you run this function. So this is a very popular method that we've developed to run software and to save a lot of money and investment when running code. There are, of course, some limitations. Not everything is so beautiful in the world. And the limitation is that when you run this code, it needs to finish in 15 minutes. So there are some compromises that we have. But on the other hand, if you have a function that is doing, I don't know, a calculation, and the calculation is very simple. I don't know, take a number and divide it by 2. This is the function that they have. I can run this function, it's take a fraction of a second to run it, and I will only pay for this fraction of a second to run the software. I'm telling you this because next week we have a workshop, and we'll be making use of Lambda functions, so it is interesting to know. But let's get back to security. So when we talk about security and we talk about VPC, we would like to have everything running inside our VPC, because we can then control you. So we can control who is accessing, and we can have security groups, and we can have NACLs. But sometimes there are services that are outside of our network. And for example, when we use a DynamoDB database like before, or when we have when we need to make use of a S3. S3 is a simple storage service that we have. In short, it is S3. We want to store some object in a bucket for use later. Those services are not running in your VPC. Those services are running actually in AWS network. And even though you're running your VPC and you're using services by AWS in AWS Network, from security point of view, you should treat them as if they're running in a public IP space. That means that if you are not running things inside your own private network, you need to make sure that the connection is secure. And the way to make sure that the connection is secured is to have rules that we can attach, who is allowed to access what, on which port, okay? But the problem is, it is not in our network. So how can we attach security groups, and how can we attach network address controls, NACLs, how can we attach them to services which are not in our network? So for this, we have what we call VPC endpoints. And VPC endpoints are designated cards or designated IP addresses that we are used to connect to services outside our own VPC. And then we can include those endpoints in our policies. And we can control and monitor who is going from where to which service, and make sure that everything is secured. So this is a way to secure the communication outside of the VPC and make sure that we maintain the same level of security. Questions about network security before we move on to the next section? Okay, I assume there are no questions. So
no questions for now.
Amazing. Either I'm very boring and then everyone went to sleep, or everything is clear. I hope that everything is clear. I rather
We got a
think this way.
feedback that the presentation is clear. We had some questions about Lambda that already been responded to.
Great, great. So let's talk about identity and access. So when we talk about identity and access management, we actually talk about who can access and what they can access. This is what it's all about when we're talking about identity and access management. We want to make sure that we know who is accessing, what can they do when they access our network, our VPC, our data, and exactly what can they access. And let's dive a little bit deeper to see each section of the who and can access and what and how everything connects together. So when we talk about who, the first thing that we talk about is the IAM users. So IAM user can be a person, or it can be an application, and I will explain shortly why. And it is a part of your account. So you know that we have an account when we create an account, that in the account we run a VPC, and when we want to define a user, we will need to define it. It will call an IAM user. There is an IAM service, and we can define the user, and the user will have his own password and a access key. A password is used to log in with the username and a password to the console, for example, and access keys are used for programmatic accessing. I will shortly talk about this. But let's go back a little bit over here about person or an application. We can grant access to a person, for example, to log in, or we can grant an access for a person to store data inside an S3 bucket, or to have an SSH connection to one of the instances. But this is not limited only to a person. We can also have, for example, an application that is doing things on behalf. So we can also have a identity attached to this application, so we know which application is accessing what. Talking about passwords and access keys. So usernames and passwords is something very trivial that we understand, but what is this access keys that we're talking about? So in AWS, everything is virtual. That means that everything is done with the code. That means that everything has an API, an application layer that I can communicate using code. When we're accessing a console on AWS, we're actually accessing an interface, and this interface is invoking API calls according to the service that we want to use. So if we want to use an EC2 instance, we're actually invoking a command to an API that will run this instance, will request this instance for us. And we can also access this API not only through the console, but we can write code. We can use a code as infrastructure as code, and define the infrastructure that we want only on a programmatic way. And in order to do this, we do not use username and password, but we use different type of credentials, which are called access keys. And whenever we want to initiate this API call, we will need to identify ourselves using those access keys. Now, the other thing that we can also do is to take those IAM users and we can group them together into a group. And this makes our life a little bit easier if we want to enforce some rules not on individual user, but on a group of users. For example, we have a group of users that are administrators, and administrators have a different set of rules. They are allowed to do everything. So we can group all those administrators, all those users that are defined as administrators in one group and apply the identity to them. Or we have users that are responsible for backups of databases. We can group all those users in one group and give them permissions, for example, on a group level to this to backup databases. So groups are a group of users that we can act to them, address them as one entity and provide rights and identify them as one entity. The other thing that we have are roles. And I think that the best way to understand what a role is to imagine to yourself you're going to an office, okay? So let's assume that you're visiting AWS offices. And when you go to AWS offices, you step in, you cannot access the elevator and go to every floor that you want. You cannot go in and open every office and every door in the office that you want. You can only access what is allowed. And how do you do this? You go to the reception, you register yourself, and the receptionist will give you a card, a special key card. And with this key card, you can go to the elevator and access only the floors that are allowed by this key card. And you can open only the doors that are allowed by this key card. And when you finish, you go out and you give your key card back to the receptionist. So roles are the same. Roles are permissions that can be assigned temporarily to a designated service or designated data. And once you finish, those policies are revoked. So it is a temporary grant to access a service or to access a data, and it's a temporarily, and after you finish the access, it is revoked. So those are the cases that I'm talking about. Who? And let's move and see when we say can access. The can access means that I can either grant access or I can deny access for something. This is when we talk about access. And the ability to grant access or to deny access can be done to who? Okay, to users or roles. So I can say a user, let's assume maybe this user is a part of the backup group. So users that belong to the backup group are allowed to access the storage, but are not allowed to access EC2s, for example. And the same with roles. I can attach the policy to a role, and I can say that the role can access, okay, only a certain data and not others. So I'm giving him this key card. I'm giving the role the key card to open only the designated doors and get to the designated flow that I'm allowing to. The other way to look on policies is from the resource type. So let's say that I'm attaching a policy to a storage, and I'm saying, okay, who can reach this storage? Who is allowed to read information or to write information to the storage? And the policy is attached to the resource itself. I can say that I'm allowing to write information to this storage only if you are a part of the administrators group. And you are not allowed to write information into this storage if you are coming from the backup group. But if you're coming from the backup group, the only policy that I'm allowing you is to make a copy of the information that I have inside. So this way, I'm attaching a policy to a resource to make sure that only the designated people, the designated identities can access this resource. So there are two ways of actually doing policies in AWS. One policy is identity-based policy, and the other one are resource-based policies. And both of the policies actually define the permissions of what a user or a group can do, or who can access which resource and what they can do on this resource. And when we say what is actually everything that we have on AWS, it can be hundreds of accounts or thousands of EC2 instances, billions of objects that we have in S3 buckets, or trillions of items that we have inside the DynamoDB database. Everything is a what? For everything we can attach a policy, and there are actually thousands and thousands of workloads in AWS that I can attach policies to, and it can be very, very granular of who can access and what they can access. Let's have a look a little bit on what we covered so far. So we have the policies, and the policies can be attached to users, to groups, to roles, or to resources. Okay. We have a formal way of declaring one or more permissions. So I can say, for example, that I'm allowing, let's say we're talking about the resource policy. I'm allowing, let me go back. I'm allowing the backup group to read information from the resource, okay? But they are not allowed to write. And if I have a look on administrators can write information to the resource, they can write information to the storage, and they can also read. So they have two types of permissions that are allowed. And I can actually grant permissions, more to permission to allow or deny. And the question is, when does it happen? So permissions are actually evaluated at the time of the request. I am setting a permission, it is over there, and once there is a request from a user, for example, to access a resource, we will first check to see if this user is allowed to access the resource. And then on the resource side, we will check and see if you have a resource policy, is this user listed in the policy and he's allowed to do this? And we need to understand that all of those policies and resources that we can control, we're only talking about the AWS services. So if, for example, you have your own server running and you have users defined over there, you cannot apply IAM policies to users which are not a part of AWS, because the users are running inside your web server, your Windows server, for example, okay? So it only applies to services, and we can have really fine-tuning of those privileges and grants that we're giving to users and groups, roles, or whatever. And let's have an example on syntax. How does it look? So a policy is actually a JSON file. And the JSON file has a few sections in there. It has an effect, an action, and a resource. So for example, in this example, we have the effect is allowed, so we grant access. When we grant access for what? We grant access to list bucket. The list bucket is an API call, and the API is S3. So S3, remember, it's a simple storage service. So we can have a list of buckets that are S3, but we can only have the bucket of S3 only if the resource is example bucket. So what does this policy say? This policy says that I'm allowing to list a bucket, an S3 bucket, only if the bucket is example bucket. And if I'll take this policy and I will attach it to a user, then this user will be allowed to list the example bucket to see what we have inside. And if I'll take this policy and I'll attach it to a group, then everyone in the group are allowed to list this bucket. And if I'll attach it to a role, then the role itself will be able to do it. Questions? Okay, so let's move on. We have a principle of least privilege. And the principle of least privilege is really a security concept. And the security concept is that we want to allow individuals, users, groups, rules to do only the things that they are allowed to do and what is necessary to do their job. So we create groups, and it is best practices what I'm showing right now. So we create group according to the job functions. As I said before, for example, we group together the administrators or the developers or accounting, and we provide them only the privileges that they know they need in order to do their job. And it is for example, let's have a look, at this policy. So what does this policy do? If I'm taking this policy and I'm attaching it to a user, okay? This policy, as you can see, is very permissive. Why? Because the allow is effect. So we grant what? What is the action that we grant? Everything. Okay, so we grant everything on which resource? On everything. This is the policy that usually a root user will have, an administrator will have, because administrator is, let's say, the god of the account. So the god of the account is allowed to do everything that he wants on any resource in the account. If we will take this policy and we will attach it to developers, we're actually turning the developers into administrators. And if we want to have a better policy, we can have the policy, for example, like this. This policy will allow the action will be to list bucket and get object. Okay, so we can list what we have in a bucket and we can get an object from an S3 bucket. And we will allow this only to the resource example bucket. So when we attach this, we're making sure that only the necessary API calls are allowed to this. And we can even go further and we can use conditions. So we can say, okay, we are allowing you to list bucket and get an object from this bucket if you're coming from the VPC network X or VPC network Y, or if you're in region US East 1 okay, or anything else. So adding conditions can make this a policy very, very granular.
I have a
Questions?
question about the version. Does it mean just a string name or actual moment in time starting as described?
No, the version is actually, it can almost be ignored. The version is something that is coming according to the statement of the policy. It is usually a moment in time. It's not until validation or something like this. This is just when we talk about we want to have maybe a few policies and we want to be able to identify them, we can have versioning for them. Any other questions?
That's all for now.
Okay, good. So let's talk about data encryption. And you know what, before I start with data encryption, another quote from our CTO, Dr. Werner Walbus. I really like this quote because he says, okay, when you're dancing, you can dance like no one is watching. But when you're handling data, encrypt everything like everyone is watching. And this is the concept that we need to have in mind. Security is number one. And we need to make sure that we secure the data of our customers, the data or your data, or if you have your customers, you need to make sure that the data is secured in all times. And when we say secure in all times, what are those times? So, for example, if we have information that we save and we put into a storage, so the data is at rest. When we store this data inside the bucket, inside storage, we need to make sure that the data is encrypted. And when we take this data from the storage, and let's say that we are transmitting this data from the storage to a different computer or a different location, we need to make sure that when the data is in transit, when the data is in motion, it is also encrypted. Because if someone is, let's say we have someone in the middle that is managing to pick up the information, we don't want the information to be revealed. So we make sure that the data is encrypted also when it is in transit. And if we have an applications, so we want to make sure that also the application code itself, we don't want to have vulnerabilities exposed and things like that. So we need to make sure that also on the application level, we have some encryptions. Now, there are actually a couple of ways in general for encryption or strategies. First one is client-side encryption. A client-side encryption means that when you store, for example, the data over here, you store it in the bucket, you have two options. Option number one, you take this data to your computer, you encrypt the data on your computer, and then you save this data to the bucket. Then you save the data to the storage. That means that whatever is in the storage is just an encrypted data. It's something that we cannot read. It's an object, you are responsible for it. The other way to do it is to do a server-side encryption. And this means that we are encrypting. So the other way to do is say, you know what, AWS, I trust you. I know that you're okay. Here is the data. Please save it into the bucket. And we will take this data and we will encrypt the data and save it encrypt into the bucket to make sure that if someone in any accidental way will be able to access this data, the data that they will see is already encrypted and they cannot really access the data. So there are two ways over here how we can do it. And encryption is not something so trivial. And when we say encryption, you know what? Let's talk a little bit about what is encryption. So encryption is taking some plain text, for example, that we have, And we take this plain text and we have what we call a data key. And we take this plain text together with this data key and we run some sort of a, let's say, mathematical function. And this mathematical function takes the data with, takes the plain text with the data key, run it and scrambles the information, and then we get a ciphered text. We get, instead of a plain text, we get a bunch of gibberish that we cannot understand. And in order to be able to understand what we have over here, we need to take this ciphered text, and then we need to use the key and run the opposite mathematical function that will take this ciphered text with the data key that we have and combine back, actually decrypt back to plain text. Now, this type of encryption that we have text and we have a data key, and we can encrypt and decrypt the text using this data key. This is called symmetrical encryption. So imagine to yourself that you have the data and you have a key and you share the key with me. You can send me encrypted text, or you will take the text that you want in the beginning. I'll go back for a sec. So you'll take the text, you provide me also the key, you take the text, you encrypt the text with the key, and you get a ciphered text. I have access to the key as well, so I can get this ciphered text, use the same key, run the opposite mathematical equation, and reveal from this cipher text using the data key the original text that you sent me. This is the symmetrical encryption. Now, we said that we had a data key, and we took this data key and we used it to encrypt the data. And after we used to encrypt the data, we have an encrypted data key. And whoever has access to this data key can decrypt the data. That means that if someone else has the key, they can decrypt the data. So what do? So we can do something very simple. We can take another key, which is called the master key, and we will encrypt the data key. And we'll save the encrypted data with the encrypted data key together. Okay, so now we have the ciphertext and we have the encrypted data key, and everything is fine. But what do we do with the master key? Well, we can take the master key and we can encrypt it with another key, and then we will have an encrypted master key, and so on. And as you understand, this can be quite heavy operation and quite difficult to do, because whoever holds the final key can actually gain access back to your data key, to your data. So it is not that trivial to encrypt. And this is something that is well known in the encryption world. And we have a service for this, which is called a KMS. So it's a key management system, and it will take care of this hierarchy of encryption keys. And we need to manage this in a way that it is secured. And let's start in combining things together. So let's talk about the hierarchy that we had before. So we have the data, and the data is encrypted with the data key, which is encrypted by the master key, okay? And they are stored together. And this is where we come into place, because we encrypt your data key with our key. And our key is being safely secured. And this is your part. You can have access to this. You can control who has access to this master key. Remember the policies that we talked before? We can actually attach a policy to this key. And the policy to this key means that you can control who has the access to this key that can decrypt your data key and then can decrypt encrypted data and gain access to your data. Now, this is on you. You need to set up the policy for this key. And the keys that are being used to encrypt your key are under our responsibility, again, with the shared responsibility model. So we have a domain key that will encrypt your key, and the domain key will be encrypted with the regional key, and so on. And all of this is hardware protected inside AWS infrastructure, and it is protected in a way that even AWS employees do not have access to it. So if you have a policy and you are the only one that can access this master key, moreover than this, if you accidentally, for example, delete it, the data is lost. We have no ways to hurt you because we don't have access to it. We don't have access, so we don't even need to protect it. And this is more or less what we call envelope encryption. Okay, this is a high level of understanding what is an envelope encryption. So we can take data, we have a key, we store them together, and we use policies in order to allow the designated service or the designated person to unencrypt the key and unencrypt the data. Questions?
Yes, we have a question. How to define end-to-end encryption process and how to apply it on EC2, for example?
How to define, again, can you please repeat the first part?
How to define end-to-end encryption process and how to apply it on EC2, for example.
Okay, so the idea is really to use keys, and the keys are stored in the KMS. So what we're doing, if I'll go back, what we're doing, we're taking all this heavy lifting, and we use a service for this, the KMS. When you define yourself, you define the master key. You save this master key in KMS. You can either import your own master key, or you can ask us to generate a master key for you, and you are responsible for the policies of this master key. And you can use this master key whenever you want. This is a service. A service has an API. So you can use an API call, and let's say that you have data inside your EC2. I'm not talking about how the data reached the EC2 at this point, but let's assume that the data already exists in the EC2. The EC2 generated the data. Now you take the data and say, okay, I want to encrypt it. You will ask for an encryption key. You will use one of the encryption keys that you have. You can take this data and tell AMS, please encrypt this for me. It will be encrypted with your data key, and then you will get back the encrypted data. This encrypted data can be stored wherever you want. Okay, and make a note that once you want to store it wherever you want, you will still want to encrypt this transaction when you the data is getting out of your EC2. So there is, this is one way. Another way to do it is to make sure that you encrypt the data on your side before transferring it to the EC2. Remember that we talked about client-side encryption, server-side encryption. It really depends on the use case that you want to have. The idea is that we have the services to allow you to run those encryption and to control who has access to the keys in order to decrypt your data. I hope that I managed to answer the questions. I'm not sure if you go back to the chat, maybe, I don't know if I got it correct and answered. Any other questions meanwhile?
Yeah, if I have another question, I will tell you.
Okay. So we talked about symmetric encryption. Let's talk a little bit about asymmetric encryption. So asymmetric encryption works a little bit different. With asymmetric encryption, we have a server side and we have a client side. So the server side actually generates two keys, a private key and a public key. And each one of the keys has a different function. The private key can only decrypt data. The public key can only encrypt data. So now that I'm the server and I want to communicate with the client, so I want to transfer information from the client to the server, what I need to do is to provide the client that has the data, I need to provide them with a copy of my public key. The client can take the public key and run the encryption and get an encrypted data. Now notice that this key can only encrypt. So if someone else gets an access to this key, they cannot do anything with it. They cannot decrypt the data because with asymmetric encryption, this key can only encrypt. And then this encrypted data is being sent to the server, and the server will use the private key to decrypt this data and gain back the data that was originally over here at the client side. Of course, that then we need to make sure that no one gets access to this private key, because this private key is actually the only thing that can decrypt this data. So when we're talking about transactions that we have, let's try and combine everything together. Just before that, we need to understand that when we see this process of asymmetric encryption, there's a lot of computing being done over here and a lot of effort, because we need to send keys, we need to encrypt, we need to take the data, send the data back, use a different key to run another function and decrypt, and everything needs to be managed, and we need to make sure that the keys are secured. And when we take everything in real life, we try to bring it to some actual real life experience, let's have a look on what we do on a daily basis, and we're not even thinking about it. So we have, for example, a web server. I'm coming back to our e-commerce web shop that is actually running a web server. And this web server has a certificate, a public certificate that says that, okay, I am the e-commerce that is called example.com, and this is my certificate. I have a genuine certificate showing that I'm who I say I am. And when an application or user is accessing this web server, this public certificate is going to the web browser of the user. And from this certificate, a part of this certificate is this public key that we saw before. So the browser now extracts the public key that is being used by the server and generates a cipher, actually, a key. So he generates a data key that he wants to encrypt with the server. And this key is being encrypted using the public key. So the application, the user, is generating another key that he will want to use to transfer data to the server. But because we don't want anyone to catch this key, because this key, if you remember, if I have the data key, I can decrypt the data. So I take this data key and I encrypt it with the public key. And then I transfer it over the internet, over the web, to the web server. Whoever catches this communication cannot do anything, because the only thing that they can have is the public key. But in order to decrypt, you will need the private key. And the private key resides only on the web server itself. So now the web server has a decrypted version of the key that was generated by the browser. And now the communication can be over here, the encryption can be over here, asymmetric. So we use asymmetric encryption to transfer a symmetric key that encrypts the data in transit between the browser and the server. And now that we have symmetric encryption, which is much lighter, we can have the communication between a secure communication between the browser and the web server. This is what happens when you reach a web server and you see this lock on the web server that is being closed. That means that you managed to extract the public key from the certificate. You encrypted your encryption data key, transferred it securely to the web server, and now the communication between the two is encrypted. Okay. So this can also be done inside services. Encryption is not only when going outside of the network to the outside world, but it also can happen, for example, if you want to access some data. So accessing data from the web server, so let's say that the user has placed an order and you want to save this order to a database. While this order is in transaction, we will also want to secure it, and we want to encrypt it. And then we need to have another certificate, for example, for this, for storing things, for storing the data that we have in transit over here. And we will get to a point that we will need to handle a lot of certificates like this. And this will need to be managed somehow. And again, this is quite a heavy lifting that needs to be done. And all of this is being, again, you have a service that you can manage all the certificates, or even have a security authority configured that is generating those certificates and managing all the secure communication outside of the cloud or inside of the cloud. And you can store all those certificates that you have in a secure store and make sure that the encryption that you're using is not only good, but is also secured and safe and sound. And this gives us actually, as I say now, another 5 minutes to some questions and answer that you might have. And if I might add just one more thing, next week I'm going to run a workshop again over here, and will be longer. And this workshop is will have a great experience of working with the AWS services. We will get to see everything that I've spoke about over here. We will get to see it in action. You will use your account. We will set up accounts for you. You will be able to run most of the things over here. Set up EC2, set up a load balancer, see how the load balancer is using auto-scaling and how everything can scale. So join us next week as well, and you will be able to see everything that I talked about, not only in theory, but actually in action. And this is time for have some 4 minutes. So let's, if you have any questions.
There is a question about, is there something I can do to prepare for the workshop?
And you don't need to do anything, actually. The workshop is taking basics. I recommend, if you want to play around a little bit, to set up an account in AWS. There is a free tier that you can use. So until you have 12 months to experiment with some services for free. I recommend to do it because it will give you a little bit of understanding, but the workshop will start from the basics. We will see how a console is working. We will log into a console. We will do everything step by step. I think this is one of the best kickstarters for you to get into the AWS network and learn about the different services.
Will they have access to the accounts during the afternoon like the last time?
Yes.
Yes. If I can apply NACL within AWS, why still need to do data encryption?
Okay, so NACL is actually configuring who can access the network, who can access your subnet. It has nothing to do with the data that is being passed. So let's assume that you have HTTP communication. HTTP is not encrypted. So if you have someone that is watching the wire, okay, and you transfer the data, and the data is being transferred, you allow only HTTP traffic, but someone manages to catch the traffic while it's in transaction. He will be able to read the information and use it, okay? It has nothing to do if he is able to get into your network and catch it. He can catch the information while it's in transaction. But if we encrypt the information while it is in transaction, then he will not be able to read the data. And if you have NACL in place, he will not be able to get inside to your network and pick up the data from there. So we secure it in both ways. We secure it both in transit and both in rest. I hope that answered the question.
Someone is asking if I am a newbie, can I join the workshop? Is it clever to come?
Yes. If you're a newbie, you should join the workshop, especially if you're a newbie. The workshop has several, I would say, levels in it, okay? And we will start from the very basic. And even if you're an advanced user, there are some exercise over there which are in a higher level. So it takes you from 0 to a hero, and you can jump from one exercise to another. They are not related. I will try and I will order them according to the difficulty level, and we will start from the most simplest thing, and we'll go, let's say, to a higher level of understanding, and you will be able through the workshop to understand step by step what are you doing and how to progress to the next step, and it's built one on top of another, so it's highly recommended.
So we have
So
a lot of feedback. The best session, consistent, clear. So thank you everyone for your nice feedback. Just
thank you
making
very
sure
much.
Ellen is aware.
Thank you very much. I enjoyed. I hope to do it sometime face to face and not watching a web camera. But thank you for joining, and I hope to see you next week on the workshop. Have a nice day.
Thank you, everyone.